In this tutorial, we're going to continue on with some of the tools available in the Accident Reconstruction Toolkit dialog. First, we'll start by creating a new drawing. We'll give the drawing a name. And let's place it in a new folder. And we'll accept the defaults, a 1 inch equals 50 foot scale, English units. And we'll go on next into the drawing setup wizard. And we'll choose a new coordinate file, and we're going to build that coordinate file from points imported from an ASCII text file. Here we import the ASCII text file. We select which file, and we OK this dialog. And we see that 31 points were read into the coordinate file. Next, it's going to prompt us whether we'd like to use the field to finish command. And we'll say next to that. Here it's going to process 31 points. And what field to finish allows us to do is, based on descriptive codes in our field data, we can automatically generate some line work, such as edge of pavements, driveways, and skid mark lengths, and things of that matter. So let's OK this. And here our points are drawn for us. The line work has come in based off our descriptive codes. And we've got a pretty good starting point for a base map. Next, we're going to create some of the terrain model. We're going to start by completing the road profile here. So let's go and offset polyline. We're going to make a 12-foot lane based off the center line of the road. And we can give that a percent slope from the crown to the edge of pavement of about -2%. And we pick our polyline, and we're going to offset it over here to the north side. Now we can build our terrain model and contours. We'll accept the defaults, say OK, and then we're going to type all to select all entities in the drawing. Anything with an elevation will be used to help build the surface model. And now we have some terrain contours drawn for us. Next, we're going to insert a symbol for the car. So we type insert at the command line and explore. And we have an Explorer type window where we can choose blocks to insert into our drawing. Here's a block for compact car. We'll double click it, and we'll place it at the location where we went off the road here. We'll accept the default scales and rotation angle. We can specify by stretching the rubber band to the side. And we're going to place one more car to show the final location where it came to rest. And a rotation as such here. Okay. Now let's get an idea of just how much drop we have from where the car left the road to its resting place. To do that, we're going to draw a polyline. And we're going to kind of give an approximate trajectory of where we left the lane to the final resting spot. Under the surface menu, we have some profiling commands. So we're going to create a profile from surface entities. We'll accept the default name. Say OK. And then we're going to pick the polyline where we'd like to create a section from. Next, we're going to pick which entities we'd like to see in the profile. What entities give us our elevations. So I'm going to select the contours that cross my polyline and hit enter. And the profile has been generated for us. Now we're going to add that to the drawing. So back under the surface menu, we can go to Draw Profile, click Add. Here's our car flip PRO. And we'll say OK. And here we have a lot of profile options. What's very helpful is to have a grid so we can have some lines to line up with our elevations. So we'll go into the setup of that. And we see some intervals set for us for horizontal and vertical axes. We'll try leaving those as the default. If it doesn't produce a easy to read profile, we can come back and change that later. And we'll say OK. OK here. And let's try placing our profile to the side. So what we have here is a cross-sectional view, or a profile, along the trajectory of our car, where it left the road at about 642-foot elevation and came to rest down near around 637 feet. We can use the layer control to give our profile some easier colors on the eyes and for printing options. And our grid. And we'll exit out. And we can also change the color of the profile. If we highlight an object, we can then come to the color control and set a color for it. This elevation change will be helpful for us when we get into the accident reconstruction tools when we're prompted for an elevation change. So let's start the accident reconstruction tools and we can start to build our report. We'll specify a new one. And we'll go into our vehicles section. We'll add the vehicle in our case. Let's look for a rather recent model, Audi. And we can enter in any optional license and registration. And we'll add that to our list, and OK. Once we've added a vehicle, it's available to us in the other tabs in each drop-down list. So let's go to the final tab for flips, vault, and yaw. We'll select our vehicle. When you choose a vehicle out of the list, any previous data entered in that was saved will be recalled for you. So to calculate a critical speed for yaw, we have three requirements: curve radius, friction factor, and the road crown grade. So using the 2-point selector button, we can go to the drawing and choose an approximate curve radius. By picking inside the lane and dragging out to the approximate center of the arc, the value is returned to us of about 100-foot radius. We have a friction factor lookup where, based on the road conditions and the speed of the vehicle, we can get an approximate friction factor. So since we're using asphalt, and we'll assume the road was wet and that the vehicle was traveling greater than 30 miles an hour, we have a range of 0.45 to 0.75 for friction factor. So we'll go with the low, say OK, and then we can choose the road crown grade. Again, we have a 2-point option where we can go and pick the grade. To get the grade, we'll use our end O-snaps. O-snaps are selectors that help you choose precisely specific locations in the drawing. If we type NEA for near, we'll have a yellow marker highlighted, and as we go near an object, that marker will snap to the location it thinks is best that you're trying to achieve. So I'm going to pick on the crown of the road, and now I'm going to pick the edge of pavement. Again, I'm going to use the near NEA keyword, and I'm going to snap to the edge of pavement. This comes back roughly with a 2% crown grade. When I hit calculate, my starting velocity and starting speed are calculated for me. These are the approximate speeds required for the vehicle to lose control on a radius of about 100 feet and the friction factor that we determined. Now if we change the friction factor to something a little less slick, let's go with the higher range of 0.75, and we calculate, the speeds increase. So the required speed on a road that is less slippery is higher in order for the vehicle to lose control. There are also report options for each of the calculators. So if we wanted to see a quick report, we can get a yaw report where our radius, friction factor, grade, and then our starting velocity and speeds are reported for us. So now we'll save our work. Now let's calculate the speeds assumed for the vault that was in our case. So the horizontal distance in the air we can measure by going to the drawing using the 2-point command or the entities command. If we choose entities, we can select our polyline that we use for our road profile. And here we get a distance of about 117 feet. The vertical distance gained or lost we can choose by picking 2 points in the drawing or entities again. Or we can also use our profile, which we had drawn previously. So I'm going to save my numbers here. And let's go out to the profile. So we had an assumed elevation of about 642 feet, and we dropped to about 637. So we have about 5 foot of elevation lost. So let's return to the accident reconstruction tools. Go to the Flips and Vault and Yaw tab, select our vehicle, and let's replace our distance in the air. And the amount of elevation loss was about 5 feet that we read from our profile. And takeoff grade, in this case, we're not exactly coming off of a ramp, rather we slid off the road, which actually has a downward grade, but we're going to assume that this is just going to be 0. And we're going to calculate. So in order to carry a distance in the air of 117 feet, we had to have a starting speed of approximately 143 miles per hour. Down in the lower half of the dialog, we know that the car lost traction at 32.6 miles per hour. It began sliding, but takeoff speed on leaving the pavement was around 143 miles per hour.